So let's talk about the production function and economic growth. So every economy has ups and downs, but over the long run, if the economy hopes to grow, it needs to be focusing on improving labor productivity. As a reminder, labor and capital are two of the four types of economic resources. The full list is land or natural resources, labor, human work effort. This physical capital that's defined here, human-made aids to production, buildings, trucks, etc. And the fourth category, entrepreneurship, or some people put this as a subset sometimes of the labor category. And when we talk about improvements in labor productivity, we need to understand the importance of human capital. So human capital is what you're doing right now in education. That is, the improvement in labor created by the education and knowledge embodied in the workforce. This can be K through 12 education, this can be basic skills training, this can be college level education, this can be you attend a workshop at your work and learn a new skill. It can be an apprenticeship. There's lots of ways to get this skill of humans increased. And it's not always just about job training. It can be also, general ed classes, understanding the way the world works better, educating yourself into adulthood, sort of seeing how the world works makes you a more sort of productive citizen as well, a better voter for sure. Some other things that cause improvements in productivity, even in labor productivity, that have nothing to do with the workers themselves are technological progress, things that happen that make through no fault or effort of their own, workers more productive than they used to be. Now, this is not to say that machines always improve the output and the well-being of workers. Sometimes machines replace workers and put workers out of a job, but that all depends on the type of technological progress, and there have been plenty of workers who have benefited from the increased productivity. Think of your accountants, your bank tellers, your engineers, anybody that uses a computer or software or calculator to do their work has become much faster and better at it. So you can think of those things as some of the important ingredients in the recipe, but exactly how much of each do we need for this meal we're calling economic growth? So the aggregate production function helps us understand that, and that is the basic model in which we look at how inputs combined make output. And the input we're most interested in is labor. It is the most important input still, not in all goods, but it's still the main cost for most firms is labor. So we really need to understand labor productivity. And the main output is GDP, or rather, real GDP per worker. If you're interested, there's some specific data from an important think tank called the Brookings Institution that estimates that real GDP per worker in China is a function of the technology, the physical capital or machines and computers per worker, raised to the 0.4 rather, and human capital per worker raised to the 0.6. So education and training is important. Number of computers and other physical capital is also important. Multiply that, though, by the amount of technology. So there's just some super important patterns to be aware of. One of the biggest ones is diminishing returns to physical capital. If you keep putting laptops in front of somebody or keep giving a farmer more machinery, there's going to yield less and less additional benefits to each one. So if you hold other resources fixed, and the state of technology is also fixed, adding more capital is going to increase your output, but at a decreasing rate. You may be wondering why we oversimplify the world so much, holding the number of people fixed, holding the amount of technology fixed. Of course, those things really do change over time, but we're trying to do something in economics we call ceteris paribus, or all other things equal, to sort of separate apart the different impact. Right? Hopefully technology is improving and the amount of capital is improving, but we need to know, for instance, if there's economic growth, Is it down to the fact that we had technological improvement, or is it down to the fact that we simply gave people more machines? Because that's going to be important for how we strategize and how we make policy and how firms make decisions. So we're trying to separate things apart by holding everything else constant and just changing one thing and tweaking one thing and seeing what happens as a result. So let's do that. Let's get our economy going, and let's do that ceteris paribus, all else equal. And let's say that we're holding the number of workers constant and technology is not improving at the moment. So our technology level is fixed. There's a certain type of processor. It's not going to get better over the course of this, this graph. So we're looking at simply these two variables. How much output do we get how much extra output do we get when we increase the number of machines or other physical capital per worker? And this is measured in dollars, both axes, right? So how much extra dollars of output, real GDP per worker, is adjusted for inflation, our output, divided by our population, or divided by rather our labor force. And physical capital per worker is obviously the amount spent on capital per worker. And we're saying this in the year $2,000, that's just to hold prices constant at some level. So we can compare apples to apples. So what happens? Well, you would hope that there is a positive relationship between these two variables, right? As you improve spending and you give some workers some machines, you'll get more output, right? So the increase of $20,000 gains you an extra $30,000 of output. And that continues. But notice that it continues the next $30,000 only yields you an extra $20,000, and so forth. When you spend the last $30,000, you go from $50,000 to $80,000 of capital. That only yields you an extra $10,000. What's going on? It's called the law of diminishing returns. Increases in output happen as you increase capital, as you increase these inputs, but at a declining rate. It's useful to remind ourselves that this happens because we're holding everything else fixed. We're holding technology fixed. We're holding the number of workers fixed. And the diminishing returns is apparent only when those things are fixed. So ask yourself the question now and see if you can graph it. Maybe pause this after I ask you the question and jot it down on your paper. What were to happen if now a new supercomputer processor is invented, or some new technology that improves productivity is invented? How would you show that on here? Pause, take a minute, think about it. And now let's talk about how that might change, right? So with a better computer, $20,000 is probably going to buy you more, right? You're going to get, across the board, the same money spent is probably going to increase the yield, increase the output per dollar spent. So nothing else has changed. There's not more people, there's not more computers, more dollars being spent. It's just that each dollar now goes further to producing output. Think to yourself a minute, so what? Why should we care? Why is something like this important to understand, especially for a rich country with a lot of capital equipment per worker already in place, like the US? Look, even the US wants to and needs to continue to grow. So for the path for the US for economic growth looks different than a country with already less capital per worker. So countries that are at lower incomes, they can continue to grow simply by expanding capital per worker, while the US might find a better strategy to be investing in new technology and shifting the curve up, because spending more per worker is going to yield a lot less, right, to the US than it is for China. So that's why you hear so much about research and development and technology in countries like the US. It matters more for us. And even for the not super rich countries, human and physical capital matter more than natural resources. In fact, natural resources have not proven to be a great source of economic growth. In fact, it's a bit of a conundrum. Countries that have some of the wealthiest natural resources end up being the poorest countries in the world. Some interesting questions have come up. The economist Robert Gordon argues that, new technologies, and he's not the only one, by the way, but new technologies maybe don't create as much growth as past technologies, electricity, the internal combustion engine, running water, central heating, modern chemistry, mass communication, movies and telephones. It may be too soon to tell. But food for thought. Here's how his model fits the data. Here's an interesting look at North and South Korea, homogeneous in almost every way except the choice of economic system. So this really sort of holds constant everything except allowing for economic system, private property, capitalism to take place in South Korea and not in North Korea. And you can see the results of the way those inputs are combined in South Korea, very different than North Korea. You're looking at electricity at night. Some reasons that growth rates differ around the world is that there's just different levels of accumulation of human capital and other things. So savings and investment spending, less new technology being developed in some places, less education. Education is extremely expensive, and it's very hard for poor countries to get over that hump. You've no doubt heard the term R&D. Research and development was invented by this cheerful fellow, Thomas Edison, and it can be thought of as different than just sort of innovation and people and entrepreneurs and geniuses tinkering with things for the love of the idea. But research and development can be thought of as a systematic, economically incentivized way to develop new technologies. And some more data to sort of support all the things that we're arguing here. Some of China's spectacular growth and pulling millions of people out of poverty over the last few decades can be explained, or should be explained at least in part, by its massive investment in education. And it's interesting that some countries that used to have high productivity growth no longer do. One famous example is Italy. And what's going on with Italy? Right? Is it due to rigid labor markets, lots of regulation? Is it political weakness or slow technology infrastructure? And that brings us to the very important question about the role of government in all of this. So government policies and government infrastructure and enforcement of property rights, these are all hugely important. They may appear invisible, and they may, to some market fundamentalists, be thought of as interfering in the market, but really you can also think of them as supporting and structuring the market, especially in modern economies where there's so much specialization and trade with strangers that there cannot possibly be trust or relationships. Government has to do those things, and government steps in and provides infrastructure. Government steps in and funds and subsidizes education. Both of these things the market just cannot and will not do enough of. Government subsidizes research and development. By some measures, the government is responsible for, fill in the blank here, what % of total research and development in the U.S.? I'll wait. 50%. And number 4, maintaining a well-functioning financial system. The boring but very necessary work of our financial infrastructure. If Wall Street ain't working, Main Street ain't working. And protection of property rights and political stability, good governance. These are all super, super, super important, crucial for economic success. If you happen to be a Roman history buff, you know all about these aqueducts. Thinking about Roman spending on infrastructure and its clear and huge impact on economic growth. There are questions about countries that were ahead and are now not in first place, like Britain. One important theory says that it's largely due to barriers in education. And the rapid growth in East Asia has been called a miracle. What's that about? Very high savings rates that then fund the loans to businesses to create expansion, very good basic education, substantial technological progress, sometimes done by forceful government action towards businesses. One particular source of disappointment for development economists is what's going on with Latin America. So this raises questions about government action and poverty, the cost of education, instability, but also questions of colonialism and the extractive practices that countries rich in natural resources, like many in Latin America, have faced. Another continent rich in natural resources is Africa. Sub-Saharan Africa, specifically, has had a century or more of heartbreak, promising economic growth that should have been there that does never materialize. So is it down to government corruption, civil wars, political instability, poor geography, and the money question? Is Africa poor because its politics are unstable, or vice versa? We could argue about that one all day long. There's some cheerful news. The convergence hypothesis argues that countries that were behind will find it easier to catch up, that differences in real GDP should narrow over time because the countries that are doing the hard work of research and development, paying the cost of new technologies, countries behind them won't have to reinvent the wheel, so to speak, and it should be a little cheaper and easier. For instance, Sub-Saharan Africa never got traditional telephone infrastructure, but they leapfrogged right over that to cell phones. And in fact, they also lacked banking infrastructure because of geography. Tough geography in many parts of Sub-Saharan Africa made it so that it didn't make sense for banks to locate in these areas, just too expensive for the market. And so cell phones not only bridged the gap for communication infrastructure, but cell phone minutes began being traded as currency, basically. So people could pay for their groceries with cell phone minutes, and now you don't need banks and you don't need phone wires. But alas, this tends to hold true more for alike countries than for poor countries, because in as much as Sub-Saharan Africa can leapfrog over certain technologies, it may lack the basic infrastructure and political stability and all the other things that are present and make growth much easier in rich countries. Quick gut check here. What do you think? Economic growth can be especially fast where? For countries playing catch up with countries that already have high real GDP per capita? For poor countries, if convergence is true? If the country is able to benefit from adopting the technological advances already used? And your answer? I think you can make the case for all of them. And the last thing, what about environmental sustainability and economic growth? Does the limit placed on growth by a limited amount of natural resources matter? How large are the supplies of these natural resources? How effective will technology be at finding alternatives? The answer is, we're still figuring it out. Here's oil prices. Oil prices certainly have their ups and downs, but through the 70s, when oil prices really started rising, and they kind of go all over the place after that, our consumption drops, primarily you could say because of increased oil prices, and real GDP didn't really slow down all that much. So it's unclear that resource scarcity and higher prices limit growth. In fact, it does not look like they necessarily do. And the causality goes the other way as well. So economic growth can cause limitations to the environment. You're looking here at carbon dioxide emissions, and China's rise, while wonderful for the world and for Chinese people, has been troublesome for climate change. And so for those of you interested, a mainstream economic consensus would be that climate change requires some market-based incentives. Carbon tax and cap-and-trade system are the favored ones. There is a cap-and-trade system in place in the U.S. for sulfur dioxide, the chemicals that make up acid rain. Started in 1990, very effective, but the U.S. has walked away from the global cap-and-trade system or tradable pollution permits for carbon dioxide. Carbon tax is thought of as maybe a more politically feasible way to go about this. It's set up to reduce some of the external negative costs of gasoline that people that buy it don't currently pay, and you would increase the taxes and therefore make people probably consume a little bit less, and that would reduce carbon emissions. And to those that think that U.S. can't possibly do such a thing because it would slow down our economy too much, well, the UN International Panel on Climate Change estimated that it would be a very small cost. It's a false choice put before us by politicians with agendas and a lot of lobbying money in their pocket that you cannot have simultaneously a healthy climate and a healthy economy.